This lesson is for FST Lesson 2.7 on inverse variation equations. I think it's important for students to have experience or information about both direct variation and inverse variation in this lesson, even though inverse is the focus. When you're working with direct variation, one variable will increase while the other also increases. So both are going up at the same time. In inverse variation, while one increases, the other decreases. So we're going to have students write down a bunch of information today about both direct and inverse situations. First, we're going to look at the direct ones when x is raised to a single power. If you have y equals kx, that's going to form a line. So we call those linear. And when it forms a line, it's either going to go up or down based on the value of the k. K is simply a constant. If it's greater than 0, the line will slope upwards. If the k is negative, it'll slope downwards. The domain and the range for this direct variation equation is simply all reals for both. Keep in mind that when a problem says varies directly or is directly proportional to the variable, they simply mean that the k and the x are being multiplied together. In inverse situations, you'll be dividing by the variable, so it'll be k over x, and it'll say either that it varies inversely or y is inversely proportional to x. In this situation, because x is on the bottom, x can't be 0, so that means there's never going to be an outcome of 0 for y either. So notice in the graph here, the branches point away from the 0 line, and they're going to get really, really close to the axes but never actually reach them. So the graph itself is called a hyperbola. And the hyperbola's branches will be in quadrants 1 and 3 when the k is positive. It'll be in quadrants 2 and 4 when the k is negative. It's important that students remember that the branches are dual, meaning there's 2 of them. And when students are making a table, make sure you include some positive x values and also some negative x values so you can make sure to get both branches pictured. The domain and the range here for the inverse equation mimics what it had for direct, with the exception of the 0. So all reals except 0 for this inverse, and again that's because you can't divide by 0. Because you can't divide by 0, these graphs are going to approach the x-axis and the y-axis but never actually reach them, so those two are the asymptotes. So typically we draw the asymptotes in as dotted lines. Alright, so remembering that k is a constant, we have 2 more situations we're going to look at. The one on the right is, again, a direct situation, but now the x is being squared. So it'll say it varies directly as x squared, so that word will have to be included. This equation is called or referred to as a quadratic, and the resulting graph is referred to as a parabola. The parabola will either open up or open down, depending upon the value of the k. The domain is going to be all reals because you can square any number that you can think of, but the outcome is always going to be either positive or negative. So we'll say it's either going to be greater than 0 or less than 0. Similarly, when we're dealing with an x squared when it's on the bottom, that is an inverse situation, and the name of both the equation and the graphs here are both inverse square. So in an inverse square equation, again, you can't have 0 on the bottom. Because x can never be 0, y is never going to be 0 either. This one looks very similar to the hyperbola up above. That first branch in quadrant 1 mimics our previous graph back here. They look almost identical. It's the second branch and its position that makes the difference. Because we're squaring that bottom number, it's going to flip that other branch up into quadrant 2. So I usually describe that picture as kind of like a volcano. It looks like a volcano or kind of like Devil's Tower. When k is negative, the 2 branches are going to point downwards and be in quadrants 3 and 4. Again, there is a relationship here between the domains and the range as you look across this list. The domain is all reals, again, except for 0. And the range is going to be either the positive or the negative, but this time 0 is excluded, so we don't have the equal sign. Because 0 is excluded, we will have asymptotes on this one as well, on the x-axis and the y-axis. If students don't like the way that this information has been organized in the notes, they can also check out the table that's in the book on page 128. It focuses on the 2 inverse operations, or the 2 inverse graphs, or the 2 inverse equations, and organizes the information presented in a slightly different manner. The next thing I wanted to do is give students a few more real-life examples of direct and inverse situations. The book gives students example 4 here of Boyle's law. The pressure of gas in substance varies inversely as the volume. To me, that one's not very real life. It's not really one that students can relate to, so I came up with 3 others. The amount of food you eat during the day varies directly as the amount of calories you consume. So both of those are directly related because as one goes up, so does the other. The time you go to bed at night varies inversely as the amount of sleep you get before you have to be at school. The later you go to bed at night, so as that number increases, the amount of sleep you get will decrease. So one is increasing while the other is decreasing, so that's an inverse situation. Here's a sports example. As the distance away from the hole increases, chances of you sinking your putt in golf decreases. Usually it's easier to sink your putt when you're closer to the hole. So hopefully those help illustrate the direct and the inverse situations for students in real life. We're going to do a quick example working with numbers and the inverse equation. And there's a 4-step process here. First, take the words that are appearing and turn them into symbols. If y varies inversely as x, y is mentioned first, so that's the dependent variable. Even though k is not mentioned, k is your constant and needs to be incorporated into your equation. Since it's inversely related to the x is going to be underneath the k. There is no square mentioned, so we don't need to worry about raising the x to any type of power. Once you've got your equation written, the next thing you'll do is substitute in 2 of the numbers that are given. Usually it's the next 2 numbers that they list in the problem. So 55 for y and 15 for x. If we solve that now for k, we would multiply both sides by 15. Keep in mind that if this were a direct situation, you would be multiplying by 15, and to get k alone, you would divide by 15. So the answer that we get here for k is that k is 825. That is the constant of variation, also called the constant of proportionality, also called the k value. So now you're going to rewrite your equation with the k substituted in of 825 over x. And now we're going to utilize that equation and plug in the number that they ask us to. So we're going to plug in 5 for x. Notice that we're not going to use the 55 and the 15. It's almost like those numbers have expired, and so those are no longer of use to us. So we're going to do 825 divided by 5, and that'll give us the y value that we're looking for of 165. All the problems that students are going to encounter in the homework are going to be very similar to this. Let's go ahead and label the 4-step process that we just outlined. First thing you should do is turn the words into symbols, making sure that you incorporate a k. Then you're going to plug in 2 of the numbers that go together and use those to solve for k. Substitute your k back in, so that would have been step 2 there. Substitute your k back in, that would be step 3. Returning your x and your y back to being letters, and then the last step is just to solve as they indicate. Students are going to encounter somewhat more complex problems, however, because they may be word problems, and so there are more things for the students to sift through. So we're going to go through question number 9 here and help students with that question from the homework. The acceleration of a falling object due to Earth's gravity varies inversely as the square of the object's distance from the center of the Earth. It's quite the wordy problem, and so students just need to grab what that first piece of information is. Acceleration of an object due to Earth's gravity. So I'm just going to call that or refer to that as simply the letter G. It varies inversely, so I know I'm going to have k over something, and then I'm going to read the rest of the problem. As the square of the object's distance from the center of the Earth. So I'm doing distance, and I need to square it. And it needs to be underneath the k because it was inverse. So I used object's distance as my other one, that was the d, making sure that I squared it. Now let's go ahead and start plugging in some numbers. The Earth's radius at sea level is about 6378, so that's a distance. And then the acceleration due to gravity, that's a g, is about 9.8. So I'm going to say 9.8 equals k over 6378 squared. To solve that for k now, I'd multiply both sides by 6378. Making sure that you square it. Typical mistake there is for kids to forget about the square. When you multiply that out, you're going to get a number that looks like this, 3.98 times 10 to the 8th. Now for a lot of students that number is very unsatisfying, so here's how you can deal with that. It's a number in scientific notation, and if you don't want to figure it out, go ahead and hit the up arrow until that number is highlighted, hit enter to copy and paste it. And now you can see the number without any rounding. So now we're just going to take that number and write it down for our k value. So our k value is that big long number. Now we're going to use that to answer the next question. Compute the acceleration due to Earth's gravity for an object in orbit 10,000 kilometers above the Earth's surface. So we're going to utilize our formula again, making sure that the bottom number is the proper distance. Remember that that bottom number needs to be from the center of the Earth, and this number is from the crust out to the object orbiting the Earth. So we need to add that to the previous radius. So we're going to get 16,378. Take my 10,000 and I add it to the 6378. Don't forget to square. So when you square that number, then do your division. And I'll leave students to figure that one out on their own for their homework. The last thing we have to do is part C. We will use the same formula again. And this time, just be careful about the number they give you. This one is from the Earth's center to the moon, so we don't need to incorporate the 6378. Just make sure that you do go ahead and square that number on the bottom.